All right. The last announcement that I recently posted is homework chapter 3B is annoying in my opinion. I don't mind if you skip it. You get extra credit if you tackle it though. And I'll show you why it's annoying. It's a lot of code you type in from the book. It's pretty cool, but it's a lot of code you type in from the book. And I think that the code is structured in a silly way in that it pops up a graphics window before it lets you type in anything. I'll kind of show you what it looks like before I edited it. Something like this. You run it, pops up a white window, it covers up your input window. That's annoying. If you really try hard, you can kill it. No, don't report the process to Windows. All right, so anyways, if I take that and I put it back to where I finally moved it to, I rearranged the code a little bit to make it work a little bit better. It shouldn't pop up the graphics window until it's ready to draw, not before it asks for the input. And so what the program does is it asks for information about two different circles. Asks for the x-coordinate, the y-coordinate, and the radius of each circle. And then it determines mathematically whether they intersect or not. Whether they intersect at 1 point or 2 points or no point. Right? Because we have a perfect circle here and a perfect circle here, and they just touch right there. That's 1 point. If you have two overlapping circles, then you have 2 points, and this, they're far apart, then they don't intersect at all. So if this one is at 10, 10 and it's got a radius of 5, ew, it blows up. All right. Why did it blow up? Because I said it must be greater than or equal to 5. I goofed it up. That's because I modified the error message. That was my fault, not theirs. But I'm going to provide a little bit better. Let's see if this will work. 29, 29, 29, 39, 39, 20. And then it draws the 2 circles. And it tells you that the circles intersect at 2 points. So why is this a cool assignment? Because it uses a graphics library. One you'll need to download called Easy Graphics. I accidentally put 2 versions of the library in there, and the Easy Graphics one is the one you're supposed to get, so I'll delete the other one. Kind of neat. You'll get bonus credit if you get it working. So, worth doing if you want. Takes a little while to type it in, takes it longer to correct the syntax errors. Sometimes the syntax errors are kind of subtle, and you don't see what's wrong. For example, I think if I did this, not absolutely sure this is going to generate. It's what I got when it was turned in. Well, it's working now. Okay. Before I was editing it, I was only getting 1 circle being drawn rather than 2. So anyways, pretty neat assignment. And if you feel like struggling with it, previous semesters have absolutely hated it. So, some people, other people haven't had much of a problem. I guess it's not that much typing, but it is a lot of typing. So, useful stuff. Maybe we'll do some other assignments with the Easy Graphics library, just because it's cool stuff. It's different than the Turtle library that we demonstrated in prior classes or earlier in this semester. All right, so we were done with Chapter 2 of the online book. You can tell how you're doing in the class so far. I mean, the grade is quite inexact, but you can make sure that you're above a 0, for example, because you'll be dropped from the class with an AW. And I think I sent out too many AW warnings. I hope not everybody received one. But you can just go to grades and look at your grades, and there should be a line item that says AW percent, and it may be 100 or 50 or, something like that, depending on whether I've graded all your homework or not. But shouldn't be 0. If it is 0, it means you didn't take the intro quiz or do anything else in the class. I'm going to go to our online textbook. We were done with chapter 2. I need to just bookmark this, but on the other hand, demonstrating conditionals. What are conditionals? Fundamentals call them decisions. Pardon me? Yeah, exactly. Yeah. So what you do is, based on the result of a logical expression, you perform some code. And some other languages have an additional conditional called an additional conditional called the switch statement. Kind of looks like this. I'm going to show it to you, and then you're going to dump its memory because Python doesn't support it for some reason. But, if you have this, if a is z is equal to 3, do something. Elif z is equal to 4, do something else. Elif z is equal to 5, do something else, right? Else, and then a final else, do 6, or display a warning message that they made an invalid choice or something like that. The way the switch statement looks is it's kind of a concise way of setting this up. You say switch based on that variable, and then you list some cases. Well, if it's case 3, you're going to do 3, and then you have to put a break statement there. If it's a case 4, you do some stuff for 4, break. Case 5, you do something to handle 5. And then if none of the above is true, it executes the default case. What do we call that? Do 6. So I don't know if I can get all this on the screen at the same time, but you can see the difference. This is a bunch of if-elifs. This is enforcing the structure. You know that this stuff is mutually exclusive, that it's only going to do one of these things. Whereas if we goof this one up, like if we just wrote if z is equal to 5 there rather than elif z is equal to 5, then it might do that. Well, in this particular case, it probably wouldn't, because z is not going to change its value. But it's not mutually exclusive if you have a chain of ifs. If you have a chain of if-elifs, they are mutually exclusive. I'm getting ahead of myself. So a Boolean expression is one that evaluates the true or false. Equal, equal is one Boolean expression. I'm going to pop open the shell, play with that just a little bit. So say I say x is equal to 5 and y is equal to 5. And then I do x is equal y. If you put a single equal there, that's bad. It's going to erase the value of x and replace it with y, which is not what you want inside of an if statement. And as a matter of fact, Python will warn you that, or Python will declare that an error. Some languages won't. And so you made a mistake, you didn't type 2 equal signs, and that's a really hard bug to fix. Trust me, I've done it. So anyways, if I did this, not x equal y, well, that's true. Because what the not did is it reversed the truthiness of the Boolean expression to follow. If x is equal to y, this evaluates to true, but then that turns it to false. There's another way of expressing that, which I much prefer, which is x not equal to y. And that is in fact true, because x is not. No, that's false, because x is equal to y. So the idea that x is not equal to y is false. Like that. Anytime you throw some nots into your logic, it becomes more difficult to read. The computer doesn't care if it's difficult to read or not, but you can write some logic that looks kind of good to you. But you see the way I messed up, right? When I looked at that first, I said it was going to be true. I was wrong. I eyeballed it, and the knot kind of twisted my brain a little bit. It's kind of like using double negatives in an English sentence, right? I can't even think of an example right now, but I ain't not going to do it. What does that mean? That means you are going to do it, but you have to parse it, you know, and sometimes people expect a double negative in the English language to mean a positive, actually. So you just have to be careful. If you need to throw some nots or not equals in there, yeah, go for it. But it can make the logic more difficult to read. It can make your mind have to go through additional gymnastics to figure it out. So true and false with capital letters is the Python way of expressing those Boolean values. So in my Python shell over here, if I do x is equal to 5, y is equal to 5, and then I say z is equal to, I'm going to put it in parentheses, but the parentheses are not necessary. I think they make it easier to read, right? There we go. It performs this comparison. It decides whether that's true or false. It stores that result in z. So if we print out the value of z, yep, that was true. If we want to find out the type of variable that is, it's a bool, a Boolean value. Boolean algebra is algebra, a numbering system where there's only two values, two numbers, you know, 0 and 1, or 0 and not 0. In other words, false and true. So you can do this, right? X not equal to y, x greater than y, x less than y, x greater than equal to y, x less than equal to y, x is y, that's a kind of an interesting one, and x is not y. I'm not sure about introducing those at this point, but let's try that. X is y. To me, x is not y, but it's equal to y. And it says here the same thing. So x is not y. That works. Cool. It's true that if x is y, then if you try to say x is not y, that would evaluate to false. So your logical operators. We have some operators. Remember, operators are the symbols that hook up parts of the expression. In other languages, and or actually are symbols. And is often represented by two ampersands. If you take C++ or Java or something like that, you're going to see that. Or is represented by two vertical bars, the one over the backslash, shift backslash. Guy who invented Python decided he wasn't going to use special symbols to represent and or. He was actually going to use the words. And I think that's a cool idea. I'm not sure why the other languages didn't do that. So the way and works is both conditions have to be true before it evaluates to true. And I know you know this from fundamentals. Or means only one expression has to be true. If both of them are true, so much the better. There's something like this. I better put a comment here. Switch is available in C and Java, but not Python. Just so you don't try to throw this into your code. So if you have X and you have Y and you have a result, and you're doing an AND, then if this is false, and this is false, I'm not going to write out the whole word, that's false because neither one of them are true. I am hungry and I have money. Both of those have to be true before I can go to McDonald's and eat. If I'm not hungry, I'm not going to bother. If I don't have any money, I wouldn't be able to do it. Both of those have to be true. So that's still false, right? I'm not hungry, but I do have money. Well, I'm going to stay home. I'm not going to waste my money. Same for that. I am hungry, but no money. I'm going to stay home. It's only when both of those conditions are true that it evaluates to true. This is what's known as a truth table. That's the truth table for AND. You can make the same table for OR. X or Y, not U, and the result. Same deal. I'm just going to stick some F's and F's and F's and T's and T's and F's and T's and T's. Alrighty. So false and false, that's like if I am sick or tired, I'm going to stay home. Only one of those has to be true. If I'm tired, I'm going to stay home. My boss may not like that. But if I'm not sick and I'm not tired, I'm not going to stay home. So the expression, the result is false. I'm not sick, but I am tired. Well, I'm going to stay home. I'm sick, but I'm not tired. That's kind of a weird state, but I guess it's possible. And if I am sick and tired, I'm doubly cursed, so I'm definitely going to stay home. Notice that when you're talking about and, there's only one state that's true, when both inputs are true. When you're talking about, and when I say inputs, in this case, they're actually operands. Input would be the term if you're an electrical engineer talking about logical gates. So if you're using and, you only have one true case, and that's if both operands are true. If you're talking about or, you only have one false case, and that's when both operands are false. You don't have to remember that. You just need to remember the truth table. Actually, all you need to remember is that for and, both sides have to be true. Now, if you ever go and take a logic course, you may be exposed to the idea that you can represent some of these by multiplication and some of these by addition. I'm going to copy this, and really I don't know that I would bother typing this, guys, for those of y'all who type the notes. If I change all the F's to 0 and all the T's to true, not 1, so this is and, expressed in binary. If this is the result, x, y, and that's the result, this looks like multiplication. 0 times 0 is 0. 0 times 1 is still 0. 1 times 0 is 0. And 1 times 1 is 1. So and can effectively be considered as logical multiplication. So guess what? That means that or is logical addition. Let's steal this table, replace the results. All right, so what's 0 plus 0? 0. What's 0 plus 1? 1. What's 1 plus 0? 1. What's 1 plus 1? What's 2? No, we're in a universe where you only have 2 possible values, so we're still going to say that that's 1. So you can see that or can be expressed as logical addition. So if you had some expression like this, x and y, or a and b. Well, and or follow the same rules of precedence as math, meaning that multiplication happens before addition. So these would be clustered together. And if we wanted to rewrite it in that logical form, you could say xy. You could say x times y, but math books tend to leave out the multiplication symbol if they can get away with it, plus ab. So this is this logic expressed in a shorter, more terse, I'm taking a logic course type syntax. Now you can't get away with doing that in this language, so we're never going to mention this again. I just wanted to tuck that away in a couple of neurons in your head. Why is it useful? Because it does remind you that if and is multiplication, it happens before addition, according to the order of precedence, order of operations. I guess we'll just make a note of that. And has higher precedence than or. If you ever have any questions about order of operations, whether it's Boolean expressions with and ors, or whether it's just, math, use an abundance of parentheses to prove the point, right? You could do this, x plus y times z. We know what that means. We're programmers. But if you feel like it, feel free. Go ahead and put that there. That'll make the more casual observer understand exactly what it's doing.
Now that's kind of a simple example, but you could write a long expression with a whole bunch of multiplications and additions and stuff like that, and you construct it, you know, in such a fashion that maybe it would work without any clustering of parentheses. If it helps you understand it, if it makes the expression clearer, go ahead and use them. I'm going to take that out. And then the not operator negates a Boolean expression. If we wanted to make a truth table for not x, and then the result, okay, well, if x is false, the result is true. If x is true, the result is false. In other languages, that's represented by an exclamation point. We see that a little bit by when we see not equal, like that. So if you're checking two different things, not sick or tired, I'm not even really sure how to evaluate that. I don't remember whether not has the highest priority or not. I'd have to look it up. But if I put parentheses around that, it makes it real clear that if I am sick or tired, this is going to evaluate to true, and this would flip it to false. So if you wanted to, you could word it like this. If I'm not sick or tired, go to work. Why would you care to do that? You know, else stay home. That's the opposite of writing this. If sick or tired, stay home, else go to work. There's a mathematical law whose name that I have forgotten that says if you want to expand this, the way that you expand it is to carry that not all the way through all of the expressions, and you flip that to an and. If not sick and not tired. That means the exact same thing. Okay, by the time that you're seeing a lot of nots in your expression, you ought to flip your logic. This is a lot easier for us to understand. It doesn't matter if it's easy for the computer to understand or not. As long as it's written correctly, the computer will run it just as fast. But writing code that is easy for humans to understand is, you know, just as, if not, is more important than writing stuff that'll run on the computer. Because if you ever come back and modify it, you want to make sure it's easy to understand. I'm going to copy and paste that and replace it back with the one that was there before I changed it. Oh yeah, that's called De Morgan's Law. For this expression to work, for any of this stuff to work, sick and tired would have to be Boolean expressions. So, you know, you might say that you have some numeric value representing your health in a game. And you might have another one that represents your wakefulness or stamina or something like that. And so, you know, your health in your game, you're really healthy, but your stamina is 1. Your character's been running around a lot. Later on, you might say sick is equal to health less than 3, right? If your health is too low, you're sick. And tired is equal to health less than 2. You're really tired if your health is less than or equal to 2. And you're sick if your health is less than or equal to 4. Once you've done that, then you can do some comparisons like that. Did you have to do it that way? No, you could have done it like this. I'm going to copy and paste this again. But I'm going to replace these with the values that we assigned up here, right? This is a variable that accepted the value of that expression. Well, we could have just done that. And this is a variable that accepted the result of this expression. We could have done that. If health is less than 4 or, okay, I goofed. I really meant that to be stamina, right? Tired was based on your stamina. Can't believe I did that. Alrighty. So, Is this easier to read than this? Yeah, probably. But there may be times when you want to store the results of an expression in a variable. And at that point, it's called a flag. Sick is a flag. So is tired. And then you can do some checks with those flags. I hope you see how these two things are the same thing. It's just that these are variables and these are logical expressions. Same difference though. They work the same way as long as you set them up with stuff like that. So, yeah, I'm not going to even bother talking about that. All right, so conditional execution. Here's the if statement, right? If x is greater than 0, print x is positive. Now, personally, whenever I did the flow charting in my version of fundamentals, I actually had our students write the word if inside the diamond, but it's not strictly necessary. When people invented flow charts, they didn't put ifs there. So, we have our Boolean expression here, and an expression can just be one variable, like we were doing with x and y, or sick and tired, or it can be an expression like that, because an expression, a single variable technically can also be an expression. Typically, I think of an expression as being more than one operand connected together by operators. And we already know enough about programming to know that how to write this in code. If x is greater than 0, print x is positive. Pretty much like this, right? Except I only had one if statement rather than an and. So if x is greater than or equal to 0, I forget exactly what it said. Greater than, right? And then print x is positive. Okay. For the vast majority of you who have taken Python already, you know the rules. After your if statement, you have to put a colon. And after your colon, you have to indent. That's how you mark off blocks of code in this language. In other languages, you don't have to follow those particular syntaxes, but they have their own syntax. Like if you're taking C or C++ or Java or other languages, you can do that. You can skip the tabbing as long as you have these curly braces there. The curly braces replace the idea of tabbing. However, tabbing makes your code more readable. So even in those languages, you should be doing tabbing, but it's not strictly necessary. When you're done with that expression, when the body of code that is subordinate to that if statement is done, then you stop tabbing. All right, print done, like that. And that can mess you up. You might do that. And in that case, it's only going to print done if that really was true. If x is not greater than 0, it's not going to print done. You just have to kind of be careful of that. And when I'm up here typing code and you're racing along to keep up with me, it can be easy to tab stuff when you shouldn't tab it or vice versa, right? That's real easy to do. Like if we have some equation that's going to use a return statement, people will quite often tab over the return statement when they shouldn't have. So then you have alternative execution. And these are different terms than we had in that fundamentals book with Cengage. I think they called them dual alternative, something like that. Anyways, that's when you have an else statement. X mod 2 is equal to 0 just checks to see if a number is even or not. How about x mod 10? Checks to see if a number is evenly divisible by 10 or not. X mod 100 would check to see if a number is evenly divisible by 100, and so on. So if you use an else statement, it sets up two branches off your logic. And I'm not going to make y'all draw flow charts. So x%2 equals 0 equals 0. Yeah, if that's true, it's going to print x is even. Else, it's going to print x is odd. So if I gave you a flow chart like that, you ought to be able to write code that matches it. Don't think I'm gonna, but you ought to be able to. But we already did that in fundamentals. And then change conditionals. which I've seen in other textbooks called an if cascade. That's when you link up all your conditions. You have more than one condition, and you link them up with elifs. I said more than one. It's when you have more than two, right? This is a dual alternative. But here we have three alternatives being executed. Either x is less than y, x is greater than y, but there's the third case, x and y are equal. And so we set that up by using elif. Elif is an abbreviation of else if. In a lot of other languages, they don't have that keyword. They actually spell out else if. Don't be surprised when you see that when you go on to another programming languages. I hope you all will. So, if x is less than y, print less than 0 or less than y. Elif x is greater than y, print greater. Else, print equal. Your final thing in a series of if-elifs and a series of change conditionals should be an else. Just to handle the idea that maybe none of these other conditions are right. Now, it could very well be that there's no way an else would ever trigger, that you would never expect this final one to happen. You may think that you've coded it in such a way that all of this stuff would capture everything. It's still not a bad idea to throw in an else and just make it print out some warning or error condition, unexpected state, right? Because if it gets to that point and you weren't expecting it to, that's a serious problem that you want, that you want to be able to handle during your debugging process. There's no limit on the number of elif statements. If there is an else clause, it has to be at the end. There doesn't have to be one, though. If it's A, it says bad guess. If it's B, it says good guess. Elif, if it's C, it says close but not correct. And here we don't have an else. What if they typed in D? They see absolutely nothing. Maybe that's what we want. Maybe not. If we had put in a final else that printed, error state, then we would know, during running pretty quickly that, oh, there was something that we were supposed to cover that we didn't. I strongly recommend always putting a final else if you have some elifs. You don't always have to use an an else if you just have a single if, right? Like this way up here. No reason to put an else there if you don't need it. But by the time you start throwing elifs in it, then the logic is getting complicated enough that you ought to have a dangling else at the end to handle, handle states that you may not expect to happen. Just like when I was giving you the example up here of the case statement. Maybe we didn't need a default because maybe we thought that the value of z would only ever equal 3, 4, or 5. But if something accidentally wound up setting z to the value of 6, it might be very useful information, in which case we might put an error message or a warning message here on this default clause, just like this. If we didn't have that there, then if z was not equal to 3, 4, or 5, then it wouldn't print anything. By taking that else out, I broke our code actually. Why do I say that? Because if z is equal to 3, which function or functions is it going to call? That's just a question for somebody brave enough to answer. If z is equal to 3, what is it going to do? Well, there's the obvious one, right? So it's going to call do 3. But is it going to do any others?
No.
Yeah, it looks like it's not going to do anything else. But it is. Why? Because since this isn't coded logically correctly, if z is equal to 5, it does that. Else, do 6. Right? So it's going to print that under all conditions except when z is equal to 5. That's probably not our intention. So I really should have left that elif. I made that change and I forgot to undo it. Why is it not displaying my favorites correctly? Is there some switch you have to throw to make... Alright, anyways. nested conditionals. X is equal to Y. Is that not true? Okay. X is less than Y. Well, if that's not true, then we would print less. Else we would print no. Notice that this flowchart is set up differently than how a lot of people send yeses off that way and nos off that way. A lot of people say that the reverse ought to be true. A lot of people don't care and mix it up. I think up here, if they were making yeses go off to the right, all of a sudden they've made yeses go off to the left. Does it really matter? No, but we've had some instructors insist that the modern way of doing it is to send your yeses off to the left. I think that's silly. Anyways, this you could write without any elifs. It's the same logic as this, right? We still have three alternatives being executed, less than, greater than, or equal. Same is true down here. Less than, greater than, or equal. But this is worded without any elifs. Right? There's one condition here, the top one. X and Y are equal. Else, if X is less than Y, print that. Else, print that, right? So all of this is conditional. It's a block of code under else. So there's no elifs involved. Great. That's how you want to do it. I think, to me, that this is easier to understand than this. In this particular case, I probably would have worded it as chained ifs rather than nested. But I'm sure that there are times when you want to word it as nested. You just have to figure out, you know, a programming style of your own and what you think makes it easier to understand and maintain. For an example this simple, it probably doesn't matter whether you do it one way or the other. There are times when you won't be able to set up a series of if-elifs that match nested conditionals, I think. This is an example, I think, that similar to one that you may have done in fundamentals. But you're trying to check to see if somebody's going to get the special rate on their loan. And the requirements for the special rate is that you be employed. Seems kind of mean, but you have to be employed to get the loan. And you have to be a recent graduate. If any of those things is not true, then you don't get it. And so I've seen this written as a nested loop. If employed, great. If recent grad, great. If all of that is true, we're going to print, congrats, you get this special rate. Else, print, you must be a recent grad. And then down here, we'd put an else, print, you must be employed. Maybe this could be written with a series of if-elifs. I think we would wind up implementing 4 alternatives rather than 3. Not sure about that. It'd be an interesting exercise rewriting that using if-elifs. I'm going to take one stab at it. If employed equals false, Python requires capital letters, print you must be employed. This is not going to work. Else, if recent grad, print you qualify. Else, print you must be a recent grad. And I've botched it. I did not do it correctly. because if employed is equal to true, maybe that's correct, maybe that's not, maybe that's not. If I was going to write this on my own, I would probably write it like this. If you are employed and a recent grad, then print you qualify. Else, I would just give out one error message. Else, you must be employed and a recent grad. Like that. That's how I would have done it. To me, that makes sense. You don't have to do everything my way. But I want you to consider that there are alternatives, and if the logic of one doesn't seem to be doing exactly what you think it should, you might consider if you can rewrite it. If something should have been written using ands, but that doesn't seem to work, then maybe try elifs. If you try some elifs and it didn't work, try using ands and ors, that kind of thing. Oh, I had a fleeting thought. This seems so important. All right, I came up with my fleeting thought. If recent grad, if employed, print, you qualify. Ignoring other considerations, if you have nested ifs like that, you can replace them with ands, right? If recent grad and employed, print, you qualify. How about ors? Are there any thumbnail rules like that for ors? So I'm going to just put a little comment here. If you have nested ifs, they can often be expressed as ands. I don't know why I'm suddenly putting my comments in hashes, but I'm going to do it. If, no, I'm going to give the example first. If you have bare feet, print no service, right? No shoes, no shirt, no service. If bare-chested, print no service. And yeah, we could have made that elif. We probably should have made it elif because we would print no service twice. But anyways, we have two if statements that do the exact same thing. If that's the same case, you'd want to use or. If bare feet or bare chest, print no service. Like that. So if you have nested, no, if you have non-nested ifs, if you have a sequence of ifs that all do the same result, then often can be expressed with or. All right, now we're getting to some good stuff. Try and accept. Maybe you didn't do this in fundamentals. This is good stuff. I mean, not that everything I talked about wasn't good stuff, but it was kind of nudging upon stuff that you've already learned. Hopefully I did some slightly different logic with it. What do you use try and accept? Well, there are multiple kinds of errors. There are runtime errors and there are syntax errors. A runtime error will crash the program. A syntax error won't let the program run. Those are two different concepts. Now Python can make them a little bit blurry because if you have a syntax error down in the guts of the program, sometimes it'll start running and then it'll crash, but it's still a syntax error. A runtime error is a state from which it cannot recover. You give it a file name, but the file does not exist, and so the program crashes because it was expecting that file to be there. Or you're trying to save to a drive letter and that drive has been ejected or something like that, and it doesn't know what to do, so it crashes. And you've all seen the one that, Windows has encountered an error and the application will close. Some variant like something like that. Windows has performed an unexpected operation, whatever. And then your application, boom, is gone, and you didn't get to save any work or whatever. So runtime errors are a drag. In some languages, if something has a syntax error, it won't even compile. If you try to give somebody a Java program, you have to correct all the syntax errors before you can give it to them. Same is true for C, C++, C#. In Python, you can ship them code with syntax errors. But now I'm going to specifically talk about runtime errors. And the simplest runtime error I can think of, well, there's a couple, is divide by 0. Most languages will not let you divide by 0. And if you type it into your calculator, 1 divided by 0, hit enter, you'll probably get an error message. And you may have seen memes about that. Divide by 0, and click on images. And it's like, okay, sorry for the bad language. Great, just great. You divided by 0. Divide by, and it's showing all these disasters because, I don't know, I guess God divided by 0 or whatever. Idiots, you divided by 0. These are all supposed to be funny. Let's laugh simultaneously. Just kidding. So anyways, dividing by 0, usually a bad thing. Let's find out if that's true in idle. I'm going to go back to the shell, and I'm going to do x is equal to 1 divided by y. And what do you know? In Python, it's not an error. Wait, not 1 divided by y, 1 divided by 0. X is equal to 1 divided by 0. Boom. 0 division error. Now, that's not a syntax error. It's a runtime error. The program doesn't know how to handle that. That's true of a lot of languages. But you can make your program recover from that. And so now I want us to all code together. We're going to do this because I really want to burn this in your brain, even though I don't think that it's introduced nearly this early in your book. It's important stuff. We can make our programs far more error-proof by using exception handling. So what I'm going to do is I'm going to pop open a new file inside of idle. File, new file. I guess I'm going to save it as lecture D. By the way, never save anything in your Python, in the guts of your Python folder, right? If you see DLLs and doc and include and stuff like that, and you start saving stuff in there, you can break Python. And I've probably said that before, but you can. You can get it to the point where Python won't even load, or idle will crash while it's loading. So just never save anything there. Always put it in your own directory somewhere. So lecture D. Can I type? Come on. Technically speaking, I probably shouldn't put spaces in my file names, but it seems to work in Python. Okay, so let's ask the user for a couple of values, and then let's do the division. All right, so I'm going to do x is equal to input parentheses. What is x? Question mark, space, end quote, in parentheses. I'm going to skip an important step because I then want you to tell me what I did wrong. Y is equal to input. What is y? Question mark, space, end quote, parentheses. And then 0 is equal to x divided by y. And then print z. Something like that. All right. Even without running this, I'm going to know that it's not going to work. What did I forget?
You gotta do input, whatever, int, another one version.
Yeah, you're right. I have to convert it from a string to a float. I'm going to specifically choose to do it to an int. Well, let me make sure that I need to do that. What I'm thinking is that some languages will generate an error, a runtime error, if you divide ints by 0, but not if you divide floats by 0. So what is 1.0 divided by 0.0? Okay, good. It's still an error. So I could convert them to floats to prove the point. And I like floats better than ints because I don't want it to generate an error just because they said 2.0 rather than 2. So x is equal to float x. And then under y, same deal. Y is equal to float y. And I know that if you pass fundamentals, you already know this, but the variable has to go on the left-hand side. You can't say, don't type this because I'm going to delete it instantly. Float y is equal to y. Can't do that. The left-hand side of the expression has to be the variable. Alrighty, I'm going to run it and make sure it kind of works if I give it good data, right? 4 divided by 3 is 1 1/3. That's good. I'm going to run it again. 0 divided by 4. Surprise, it's 0. How about 4 divided by 0? Kablooey, it blows up. So what we're going to do is we're going to catch that error, that runtime error. Other languages call it exception. I don't see it calling it an exception here. I see it calling it an error. Just kind of know that those terms are synonymous, that when you go onto other languages and you hear the word exception, you know what it means. It means error. It's a special kind of error. Okay, so what I need to do is I put the word try here, and I tab that over. Tell you what, I'm going to tab that one over too. Then I'm going to stop tabbing, and I'm going to say except, and then print. Oh no, can't divide by 0. Now on some other languages you can catch more than one kind of error. The except statement, which is actually written as catch, that's why I keep using that word, can figure out if the error that happened was a divide by 0 error or a format error or whatever. What if there was another possible error that could be generated by this statement and we wanted it to print a different message? I honestly don't know how to handle that. It hasn't occurred to me. But this is a little bit better. We have written our code to be a little bit more fail-safe. If we want to, we can make the program die at this point with an exit statement. Something like that. Why would you do that? Because maybe we're going to do something with z underneath here. If z is equal to 0 or 1, print cool, a 1. If we didn't have that exit statement, which I'm going to indicate by commenting it out, we would get into a problem if our result was supposed to be, oh no, can't divide by 0. First I'm going to type some good data. 2 divided by 2, it says cool, a 1. I'm going to test it again and give it some good data, but it's not going to equal 1. 3 divided by 2, 1.5. Now it didn't print our special message. That's fine. What happens if we divide by 0? 4 divided by 0. Well, there's another error. Maybe I should have handled that one. Hey, that looks like a Japanese smiley. Alrighty, so I'm going to run it again. 4, 0. Now our error got caught with that except statement, but it still blew up later. Why? Because after this, we no longer have a valid value for z. That has just really messed up the rest of our program. Now, is there more than one way to fix that? Yeah, we could take this logic and put it in the try block here, right? I could cut that and paste it here and tab it over and stuff like that. The other thing I could do is just kill the program with extreme prejudice at that point. So it stops running if it gets that error. Maybe that's not what I want it to do, right? If you get an error state, you probably don't want it to do the Windows trick of just giving you an explanation and then killing your program. So this is probably a bad idea. But I do want it to demonstrate. And it says, your program is still running. Do you wish to kill it? Well, if I click cancel, it doesn't seem to do anything different than if I click OK. Anyways, that's a way to get a program to stop executing. What does the 1 mean? It means that it would pass that value back to the operating system to be inspected. You can make programs return error codes that can be expected by the script or the CMD file that launched the Python program. Are we going to do that? I don't know. That might be a cool idea. But alrighty. We have made this program more fail-safe. Is it perfect? No. Why do I say that? What if we type garbage here? Runtime error. Could not convert string to float. How would we fix that? We could also put this in a try except statement. What would be the best thing to do, ideally? Not just kill the program because they typed in a bad value of x. What would be better behavior? I know somebody has the idea.
Another error message?
Yeah, not only an error message. If they type in a bad, yeah, that's correct. If they type in a bad value of x, we want to display an error message, letting them know what they did wrong. But then what do we want to do? Kill the program? What if we didn't want that? Pardon me?
You can input again.
Yeah, a loop to give them a second chance and a third chance and a fourth chance. Just like when you're doing a file save, but another application has that file open. Windows will crank up an error saying, file is in use. But then you go get a chance to close that file and try to save it again, rather than just kill the program. We're not quite there yet, but I am going to put a try and except around here. This is the dangerous part right here, right? Not this. It'd be okay to put both of them in the try block, though. Maybe it'd make the code look a little bit better. So I'm going to stick try here. And I'm going to tab this stuff over. And if that conversion fails, it's going to trigger the except code. Print. That wasn't a number. Then our choice becomes, what are we going to do? Looping would be the best thing, but we don't have a loop set up here. There's no while, So I could think of two choices. One is to kill the program like we did with our exit statement. And it's okay if nobody comes up with the other idea that I'm thinking, but what could be another alternative besides killing the program and besides asking them for a new value? Is there a third option? What might you want it to do if they type in bad data? Have you heard the term default, right? We might want to default to something. Print x will default to 1. And then set x equal to 1. Right? That doesn't kill our program. It lets our program continue. We probably didn't want x to be equal to 1, but it might be better than, than killing it, which is our other alternative if we're not going to make it loop. I want you to modify this chunk of code to do the same thing, to have a try and an except block. And if they type in a bad value for y, default it to 1. So to fix it, I'm going to try this, and then I'm going to do the same thing. And me being lazy, I'm just going to copy these 3 statements and paste them. But I'm going to have to make a couple of changes, right? I'm going to have to change those x's to y's. Print that wasn't number. Y will default to 1. Y is equal to 1. Okay. Now, one way to make your program almost error-proof, or not error-proof, incapable of generating a runtime error, would be, don't do this because I'm going to immediately undo it. This is really poor style. Put a try there up at the very top, tab everything, and then print, bummer, we had a runtime error. Right. We've enclosed the entire dang program in a try except. So no matter what goes, if anything goes wrong, then it would come down here and print, bummer, we had a runtime error. Now that's dumb because we wouldn't tell them what was wrong, right? At least they wouldn't get a runtime error message, but it would still kill the program, right? It would just kill it after displaying a message. So that's bad form. I'm going to undo those things. So like I said, if you typed that, unfortunately, I'm going to make you delete it. All right, now I need to unindent all that stuff. To unindent and idle, you probably already know this, but you can choose Format, Dedent. Okay, so we've written some code that is far more bulletproof. And by bulletproof, I mean that it won't crash due to bad data. That's a good thing, right? You don't want League of Legends to, stop running just because the server encountered some, some kind of error. Somebody's health went negative or something like that. You don't want Call of Duty to crash and go back to some kind of prompt or, freeze your PlayStation or something. You want it to be able to handle the errors. In a large company, you may have a testing department that tests all the code that you write. And then if they generate an error, they get to jump up and down and brag that they caught your error, and you hang your head in shame. I'm kind of kidding. But your goal is to write code that won't break. You have to try to handle expected error circumstances. Now, there'll always be unexpected error circumstances. You can think you've handled everything, and then some user will figure out a new way of breaking it. That's just a fact. But you can try to handle the common ones. The most common one we will see is somebody typing in bad data for an input statement. Okay, I'm tempted to work this out so that it would loop until they typed in good data, but I don't feel like introducing that at this point. I am going to put this as an example of error handling over here in our notes. So I copied that. Use try except to catch runtime errors. Example. The float function will crash if it tries to convert a non-numeric string. Here's code that handles that. Or do that and then just exit. That wasn't a number, ending the program, and then exit. I pretty much want you to write programs that do not crash if bad numbers were entered. Better put a default in it or loop to make them enter good data. Now, you don't have to modify code that's in the book, right? You know, if the assignment says type in these lines of code from chapter 3, no, you don't have to change it. Hey, that'd be a good idea. I ought to do that. But no, you don't have to change their code. But when you're writing an assignment for me, if I ask for input, I want you to handle bad input with some kind of try except. Either kill the program or give a default value. Those are the things that you know how to do right now. Later on, don't kill the program. Either have it provide a default error or better loop. We're almost at the end, are we not? Okay. And we're only halfway through the chapter, so I can't put a little note to that effect. Here's our example, right? Input your Fahrenheit temperature. Fahrenheit is equal to float input, then do your conversion, and then print out the result. But if it failed, you'd display an error message. Now, would this be the error message I would display? Please enter a number. In this case, not, because that implies that they could type in a good number. Let me show you what I mean. I'm going to put this at the bottom of my code. You don't have to type this. But if I just paste that there, and then I run the code, what is X3? What is Y3? Cool, enter Fahrenheit temperature, and then I type in some bad data. It says, please enter a number. And I'll go, okay. And then I wonder what it's doing. Right. So I would not have made it say, please enter a number. I would make it say the input should be a number. Something to that effect. And then print done to let them know that, you know, the program is done. A lot of newbies will, after a program runs, think that they can rerun it from the shell. No, you always have to go over here and run it, either from the Windows interface or with the run module option. I think that that's probably a good place to stop. Let's see if we have enough homework queued up. It doesn't affect us since this is a Tuesday, Thursday class, but if you have Monday classes, stay home on Monday, Labor Day. Yeah, we have stuff going out all the way to September 12th, so I think we're good to go. I'm not going to assign anything new. But after this, if something asks you to enter, like this pay calculator one, we've kind of done the same thing probably already, but maybe it calculates over time as well. If it asks for the number of hours, don't let them type in bad hours, right? Don't let them type in letters, that kind of thing. By the way, one down here is going to be extra credit. What I want you to do is watch a video or follow a tutorial document, I forget which, and just say that you watched the video. You know, upload that. And if you can get it to work, great. If you can't get it to work, no problem. Just say that you watched the video. I want you to have the idea. And the idea behind that is that you would be able to run Python from the command prompt. You could type Python and actually have it work. Now, on this computer, it's set up. On your computer's there. Maybe it's set up, maybe it's not. If on your install on your computer at home, you could give it a shot. See if you can launch a command prompt and then type Python and see if it runs into that. If you can, that's great, because that means you could run Python commands from the command prompt. I mean, you could run Python programs, the things that end in .py. All right, let's make a Dropbox for ourselves and call us done for the week. This will be Dropbox D. There weren't very many ifs in this, but that's all right. Like I said, there's some things that I'm trusting you know from taking fundamentals, and how to use if is one of those. Alrighty, if you refresh your Dropbox or click on assignments again, you'll see Dropbox D. Go ahead and give me your file, please. And we are done for the day. I have a few minutes that I can hang out before I go to my next class if you have questions or homework.